Hello, today I'm going to talk about the concept of R squared. Now R squared is sometimes called the coefficient of determination or the multiple coefficient of determination. In essence, what is R squared? Let's say that you're doing a design experiment and you've used several variables to try and explain some response variable that I'll call y. The proportion of all of the variation in this response variable y that's being explained by the model, that's R squared. Now a lot of people don't like the use of the term explained because we have to get into the argument that association does not imply causation, and I accept that, so I'm using the term explain in a very broad sense here. Let's say that we are doing a design experiment, however. If you get an R squared value that some people regard as being low, let's say like 40%, 50%, then quite frequently people will dismiss out of hand those results. Flip side of that, sometimes you may get an R squared value of 99% and people assume that it's a very useful model. Not necessarily. It's not a one-size-fits-all. You have to be concerned with what it is that's going into this mathematical model. For example, let's say that you are doing a design experiment and you've done 16 runs and you've thrown in 14 variables. Your value of R squared is going to be very, very high indeed. But have you really explained what this response variable is doing? Not really. What you've done is you've explained a lot of the noise by having a lot of variables in this mathematical model. How useful is this model going to be for predicting future values? It's probably going to be very poor indeed. So as well as looking at R squared, I like to look at other statistics as well, like predicted R squared, which will tell you how well this model will be at predicting future values, and also adjusted R squared. That's the value of R squared that's being adjusted for the number of variables that you have in your model. If you have a high ratio of explanatory variables to number of runs that you've done, you're really just explaining noise. So I like to look at it from a broader perspective. Flip side of that, let's say that you get a low value of R squared, like 30, 40, 50%. If there's an awful lot of variation in your response variable y, and you've done something like a screening design, a fractional factorial design, and okay, you're not explaining a huge proportion of this variation, but you are finding a few important variables that you think it might be worthwhile to investigate further. That's the whole point of doing a screening design. You're trying to find the important few as distinct from the trivial many. Then I would not dismiss this regression model, not at all. I would be looking at those explanatory variables and assessing them. So I hope this has been useful. The convention that sometimes people say your R squared value should always be greater than 0.95 or whatever it may be, I think that's disingenuous. You need to look from a broader perspective. The amount of data that are being used, the number of explanatory variables, more goes into the value of the computation of R squared than just is it high or is it low.